side, then two tangents are possible, right? Now there is a theorem regarding length of tangent. So please write down. The length of two tangents drawn from an external point to a circle are equal. So its proof can also come in the exam, and earlier also it came many times in CBSE exam. So basically we have to show that let's say we have a circle, right? And then we have an external point, and there are two tangents on the circle from this point. So one tangent will be this, right? Another tangent will be this. Please draw it properly. So basically I have got now 2 points of contact. One point of contact is this, another is this, right? Let's say this is the center of the circle, and I gave some name. Let these points are P, Q, center is O, and let's say this point is A, right? Okay. So what is given to us in this? So nothing, AP and AQ are two tangents, right? To a circle, let's please. AP and AQ are two tangents to a circle. We can give name to a circle. So we denote it by C, whose center is O, and let's say the length of radius is small r. This is how we name a circle, okay? Yeah, Martin, can you hear me now?
Yeah.
Okay, fine. So we are doing the proof of this theorem. Now to prove, so we have to prove that the length of tangent AP is equal to AQ, right? From the same point, the length will be equal. We have to prove it. Now let's do the proof. Okay, so before proof, we will do one construction here. See, we don't have any triangle, we don't have any figure here to prove, right? So we have to make a figure. So we do a construction. First of all, we join this AO, then we join OP, and then we join OQ. So join OP, OQ, and OA. Now start. See, it's very simple. We have to prove AP and AQ are equal, right? So if somehow we show that this triangle and this triangle are congruent, so by CPCT, AB will be equal to AQ, isn't it? Yes, okay. Now, okay, before starting, can we see three things in this triangle? First of all, I can see AO is common, right? Right?
Yes, ma'am.
Okay. And okay, so this side basically I have to show equal, right? Okay. Now this side I have taken. Now what about this third side of the triangle? Are they related?
Yeah, the red radius is
Yes, both are equal because they are radius. Okay. So two sides I have got. Okay. Then one more thing I need. What can I take? Now sides are over. Okay. Third side I have to show. Now come to angles. Is there any angle which is equal here?
90 degree.
Exactly. So I can say this is angle 1 and this is angle 2. So from the theorem, we know it is 90 degree, right?
Yes, ma'am.
Okay. So in triangle OPA and triangle OQA. Okay, so first of all, AO is equal to AO, which is common. Then we can say OP is equal to OQ. Both are radii, right?
Yes.
And angle 1 is equal to angle 2. Why? Now write the theorem. Tangent is perpendicular, right? Tangent is my screen visible or it is just blinking?
Yeah, man. I mean, it is blinking, crashing a few times.
Yeah, okay. Some network issue is happening, I think. Okay, so tangent is perpendicular to the radius at the point of contact. Okay, so we can say by which criteria is it now?
Says
SAS. No, first of all, it will not be SAS, Martin.
that
See,
RHS one.
R. Okay, if you are saying SS, it can be SSA, right? See here, I'm taking this side, I'm taking this side, and then angle. Okay, so the angle is not this one. So if it is the between angle, so we call it SAS. Understand? If
Yes,
the
ma'am.
angle is coming after the side, we call it SSA. Understand? Like that. I mean, this A is not the included angle. Now because we have a 90-degree angle, so we can think of RHS also. So one hypotenuse we have included, which is AO, and one side we have included and 190 degrees. So we can say RHS criteria. So by RHS criteria, triangle OPA will be congruent to triangle OQA. And by CPCT, we can say AO is equal to, sorry, AP is equal to AQ. Okay, then let us start with the exercise 10.2 now.
Can you scroll up? I want to see the theorem.
Yes, okay.
Done, ma'am.
All right. Okay. So in question number 1 to 3, right? Choose the correct option and give justification. Okay, now what is the question? First, from a point Q, the length of the tangent to a circle is 24 centimeter. Okay, and the distance of Q from the center is 25 centimeter. Mm, okay, so this figure is not for this question. Okay, this figure is for second part. So for first part, you have to draw, right? Question number 1. You have a circle from a point Q. The length of the tangent is 24 centimeters. So there is a point Q, right? From this point Q, you have a tangent. let's say this, right? So if this point is Q, so up to this point of contact, the length is 24 centimeter. Okay. And the distance of Q from the center is 25 centimeters. So if this is the center of the circle, let's say O, so this distance will be 25 centimeter. The radius of the circle is, you have to find the radius. Give it some name P. I think this is simple, right? Now write everything given. First of all, what is given? Uh, Name it like this, xy, right? So first of all, xy is a tangent. This is given. Then PQ is 24 centimeter. OQ is 25 centimeter, right? And to find OP, right? You have to find OP. Now, solution. So this can be done from Pythagoras theorem, right? But for that, we have to show that the angle is 90 degree. Okay. Okay, now who has joined? Abdullah. So late. Okay, so we have to show that this angle is 90 degrees. So we can use the theorem to show. So since xy is a tangent, right? So that means your radius, which is OP, is perpendicular to PQ, isn't it? Sorry, xy. Is that clear? Now write the theorem in bracket. Why? Because tangent at any point of a circle is perpendicular to the radius. Through the point of contact. Abdullah, can you hear me? Okay, you are late in the class. Okay, just take a screenshot, okay? I'm just scrolling up. So basically, I have started with this theorem today that if from any external point A, if you draw two tangents to a circle, so the length of those tangents will be equal, right? So anyway, proof is also given in the book, but if you want to take a screenshot, you can take. Right? Now, with the help of this theorem only, I have started the first question of exercise 10.2. So this is what I'm doing here. So because xy is a tangent here, so that means OP, that means the radius will be perpendicular to the tangent. We have already done this theorem in the previous class. So we have got angle OPQ is equal to 90 degrees. Is that clear? Now we can use Pythagoras theorem. So using Pythagoras theorem, so basically this is the triangle now I have OPQ, which is 90 degrees. So this is 24 centimeter, this is 25 centimeter. Okay, now all of you find OP. Please find it and tell me. Yes, Martin. How much is OP?
9 centimeters.
9, 7, 7, 7.
Yes, okay. OP will be 7 centimeter. Has everyone got it? So your option A is correct here, right? Option A. This is correct. Now come to question number 2. Please read the question in the book, all of you. Sorry, I have to insert again. Yes. Have you read the question in the book, all of you?
Yes, ma'am.
I'm sorry, actually my internet is a bit slow. It's taking time to upload. Okay, right. Now question number 2 is here. So in figure, okay, TP and TQ are two tangents, fine, to a circle with center O. So that angle POQ is 110, right? Then angle PTQ is equal to, that means, okay, this angle you have to find. Okay, can you guess something? What should we do here?
Since from tangents,
Hmm.
and then both the angle
Hmm.
OPT and OQT equal to 90 degree,
Exactly.
then we can use the quadrilateral
Hmm.
like sum
Very,
60.
very, very good. Very good, Martin. So we have already done quadrilateral chapters, right? So first of all, we will show that this angle and this angle is 90 degree. That we know from the theorem, right? That the tangent is perpendicular to the radius. And then three angles of the quadrilateral we have, we can find the fourth angle, isn't it?
Yeah.
Yeah, so just write it properly, whatever is given to you, solving it, right? So the solution, we can start with one tangent. So since TP is a tangent, so that means OP will be perpendicular to TP. Okay, why? Tangent at any point of a circle is perpendicular to the radius through the point of contact. Okay, so that means angle OPT is 90 degrees. So one angle we have shown. Similarly, we will say that TQ is a tangent. And therefore, in this figure, OQ is perpendicular to TQ. And you can mention the same theorem here. And therefore, angle OQT is 90 degree, right? So now in quadrilateral OPTQ, OPTQ. So I'm just drawing here, right? This is OPTQ. So this angle is 90, this angle is 90, and this is 110 degree. So First of all, name the angle. So angle PTQ plus angle TQO plus angle QOP plus angle OPT is equal to 360 degree. Any problem? Angle sum property of quadrilateral. Angle sum property of quadrilateral. Okay, now putting values. So angle PTQ we have to find, plus TQO is 90 degree. This is 110 degree plus this is again 90 degree is equal to 360 degree. Now quickly find angle PTQ from here. Yes, Abdullah, how much is PTQ? Subhana?
70 degree.
Yeah, okay, 70 degree, right? So in the question, which option is correct? Angle C, sorry, option C is correct. No, C. Sorry, the second question. B, I'm sorry, it was B in the question, not C. So option B is the right answer. Okay, so if tangent PA and PB from a point P to a circle with center O are inclined to each other at an angle of 80 degree. So that means this angle is given. So if you have a circle, so you have a circle, right? And then you have a point P. You have, sorry, you have two tangents now. So this is the point P. So if tangent PA, so one tangent is PA and another tangent is PB with center O are inclined to each other at an angle of 80 degrees. So this angle is given now, 80 degree, right? The tangents are inclined to each other at 80 degree. Then angle POA. So you have to find this angle. This is just the opposite of the question we have done. Now quickly solve it and tell me. The same way you have to do. No, I think how much is 90 plus 90 is 180, 180 and then plus 80 will be 16, 260, right? And then 360 minus 260 will be 100 degree. I think 100 degree is not the part of the. Oh, I'm sorry. You have to find only POA, right? I have mentioned the wrong angle in the figure. That's why I'm thinking 100 is not there. Please correct everyone. Please draw the figure again. So basically, you have a, right? Then there are two tangents here. P, A, B, and this is the center O. You join them. So this angle you have to find only POA, this much, Martin, right? And this complete angle is 80 degree given to you. Understand?
Yes, sir.
Okay. So that means you have to work in a triangle, not a quadrilateral. Understand?
Okay.
Hmm.
So, it'll be 40. AP will be 40.
Yeah, but we don't know whether this is angle bisector or not, right?
Yeah,
We cannot simply divide the angle like that. If we know that these two angles are equal, right? If we know that this half angle and this half angle are equal, then we can divide it into two equal parts. Understand? Everybody getting it? No
yes,
response. See, if I can show that angle 1 and angle 2 are equal, then I can say that angle 1 is equal to angle 2 is equal to 40 degree. Because the complete is 80 and both are equal, so obviously 1 is 40. Clear? And this angle I already know 90 degree from the theorem. So first of all, I have to show these two triangles are congruent, right? Then by CPCT, I can show that angle 1 is equal to angle 2. And that will give me angle 1 is equal to 40 degree. Is that clear, everyone?
yes.
Subhana, is that clear? Okay, Abdullah. So when this triangle, now I have got angle 1. After that, I can use the angle sum property of the triangle. And then we can find angle POA. Is it clear? So let us start. This figure is wrong. Mm. So first let us show that this angle is 90 degrees. So same we write that PA is a tangent and therefore OA will be perpendicular to PA. And then you can mention the theorem. I'm not writing it. Okay. And therefore angle PAO is equal to 90 degree. Is that clear, everyone? And similarly, again, in the next other PB is a tangent, right? So that implies the radius OB is perpendicular to PB, and that implies that angle OBB is equal to 90. No, OBB is equal to 90 degree. Is everyone getting it?
Yeah, ma'am.
Okay, other people are not here. Arshia is here, right?
Yes.
Okay. Now let us try to show the two triangles are congruent. So in triangle OAP and triangle OBP, right? Now three things, tell me quickly. One angle is 90, one side is common, and OA is equal to OB, which is radius. Okay. Okay, so I'm writing here so that you can see in the figure. First of all, OP is equal to OP, which is common, right?
Yeah, ma'am.
Then OA is equal to OB, both are radii. Okay. Third angle, this PAO is equal to angle PBO, which is 90 degree each, right? We have proved. So the two triangles are congruent. So triangle um, OAP is, okay, which criteria? RHS again. So from RHS criteria, they are congruent. Okay, and by CPCT, angle 1 is equal to angle 2. Is that clear now? Okay. So in this, oh
Let
yeah,
us scroll up.
yeah, okay. This can also be shown by SSS criteria here, right, Martin? Because there's another theorem that the length of the tangent are equal, right? So if we are not taking
Oh,
this
yeah.
so if we are not taking this 90-degree angle, we can also take that AP is equal to PP, because from any external point, the length of the tangent is equal. So anyway, you can show. So ultimately, you have to show congruency, and then by CPCT, angle 1 is equal to angle 2. Is that okay? Okay.
Yeah.
So now this complete angle, which is angle APP, this was 80-degree, right? So this angle can be written as angle 1 plus angle 2 is equal to 80-degree. Now angle 1 and angle 2 are equal. So angle 1 plus angle 1 is equal to 80-degree. I mean, if you want to show, otherwise from common sense also you can write. Is that okay?
Yeah.
Okay. And because angle 1 is equal to angle 2, so therefore angle 2 is also 40-degree. Anyway, you need angle 1 only, because we are not interested in the second triangle. Okay. So angle 1 is 40. Now you come to this triangle AOP, right?
Yeah.
So one angle is
I
40.
know. POA.
Yeah.
Right?
POA, yeah. POA. So now this is the triangle. If I'm drawing here, sorry, not like this. This angle is 90, right? So this is PAO. So you have to find this one. And this you have got 40. This is 90. So in triangle PAO, now you have angle APO plus angle PAO plus angle AOP. This is 180-degree angle sum property, right? Please write it.
Yeah.
So APO is 40-degree, PAO is 90-degree plus angle AOP, so 180-degree. So that means this is 130-degree plus angle AOP. This is 180-degree. So angle AOP is 180-degree minus 130-degree. So angle AOP is equal to 50-degree. Okay, question number 4 now, Martin. Now, prove that the tangents drawn at the ends of a diameter of a circle are parallel. So if you have a circle with center O, so let's say this is the diameter A, B, and the center is O, right? So you are drawing two tangents here. One tangent is this, another tangent is this. Now you have to show both the tangents are parallel. So give it some name. So let mark this point as PQ and RS. Okay, so what is given now? Uh, PQ and RS are two tangents to the circle. Let's say C, whose center is O and radius is R. And AB is diameter. So all these terms are used in the question, right? AB is a diameter, like that. Now to prove, you have to prove that PQ is parallel to RS. Okay, Martin?
Yeah.
Okay, let us do the proof. See, its proof is simple. First of all, we will show that this angle is 90 degree. Okay, this angle is 90 degree. We can show it from theorem, right? Then we will show that this angle is 90 degree. Again, from the theorem, we can show. And now, um, will I say? I mean, from the converse theorem, then we can say, isn't it? I mean, we know that between two parallel lines, and if we have a transversal, right? These two lines are parallel, let's say, and there's a transversal. So if there's a theorem, right, that this angle and plus this angle, the co-interior angles are supplementary, isn't it? Yes, Martin?
Yeah, ma'am.
Or in fact, we can also say uh, if this is a parallel line, these two are parallel lines, and for example, I have a transversal like this, isn't it, Martin? Yeah. Yes, Martin. So if the lines are parallel, so we know that this angle 1 is equal to angle 2. Why? Because they are alternate interior angles. You know this, right, Martin? And the converse is that if angle 1 is equal to angle 2, then the lines are parallel. Is that okay? Yeah, remember, Martin?
Yeah, wait,
Oh,
this is alternate interior angles.
no, no. Just try to recall here, first of all. If angle 1 is equal to angle 2, so that implies that line L is parallel to line M. This you already know, right?
Or,
Okay. I mean, both way it is correct that if line L
okay.
is parallel to M, then angle 1 is equal to angle 2. And the converse theorem is that if angle 1 is equal to angle 2, that means the alternate interior angles are equal. That means the lines are parallel. Is that okay?
Yes, ma'am.
So we know, if we show that this angle 1, and we can take this angle, no issue. So if angle 1 is equal to angle 2, and AB is a transversal, so that means alternate interior angles are equal, and therefore the lines are parallel. So that way we can show it.
Okay.
Yeah. Co-interior theorem also we can use, and alternate angle theorem also we can use. I think alternate is easy. So let's do it that way. So first of all, we start like this, that PQ is a tangent. Yeah. So therefore, OA is perpendicular to PQ, right? Can you write the theorem yourself, Martin? I'm just leaving it.
Oh, yeah.
Okay. And therefore, so this implies that angle 1 is equal to 90 degree, right? Now again, another tangent. So RS is a tangent. Yeah, also write the point. PQ is a tangent at point A. Please write. Is a tangent at point B. Okay. So therefore, OB is perpendicular to RS by the use of theorem, right? Please mention the theorem here. And that implies that angle 2 is equal to 90 degree. So either angle we can take, right? Left or right, no issue. Both are 90. So ultimately they are linear pairs, so 90. So angle 2 is 90. Okay. Now you come to lines. So we write like that. Now for lines PQ and RS, right? Uh, AB is a transversal, right, Martin? So
Yeah.
okay, I'm writing only lines, not parallel lines. I have to show that they are parallel. So for lines PQ and RS, AB is a transversal and angle 1 is equal to angle 2, right? Proved. So since the alternate interior angles are equal, are equal, uh, therefore, sorry, therefore the lines are parallel. Yeah. Or we say PQ is parallel to RS. All right, Martin, next question now.
Okay, ma'am.
So prove that the perpendicular at the point of contact to the tangent. First of all, let me draw a circle and a tangent. Right. So A, let's say this point is P and this point is P. And this is the center O. This is the radius OP. Now prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. Uh, so ultimately what you have to show here, Martin, prove that the perpendicular at the point of contact. So perpendicular at the point of contact is actually OP, isn't it?
Yeah, ma'am.
Passes through the center. Uh, so ultimately you have to show here that OP is perpendicular to AB, right? Okay, so we will anyway write down what is given first of all, then I'll show how to do it. So here AB is a tangent at point P to the circle, let's say C, whose center is O and radius is R. So you have to prove that OP is perpendicular to AB. So now let us start. So first of all, we know that okay, same way, since AB is a tangent at point P, right? So that means OP is perpendicular on AB. Uh, I think you will be confused now because I think this thing we have to show, right? So you can add that and mm, okay, I'll write it afterwards. First you do the proof, then I'll show. The OP is perpendicular to AB. Is that okay? So therefore the angle OPA is 90 degree. So this much you know. Let's call it result number 1. So let us assume some another point here. Let's say I assume any point here X, right? I join it. So let us assume a point X, right? Such that XP is perpendicular on AB. So this is an imaginary point, right? So ultimately I'll show that this will not pass through the center. OP is the only line which will pass through the center. Is that okay? So I'm taking an imaginary point X such that XP is perpendicular to AB. Is that okay? And if XP is perpendicular to AB, so therefore the angle XPB has to be 90 degree, isn't it?
Yeah, ma'am.
Okay. Mm. So if I call it result number 2, now from 1 and 2, Now, because the right hand side are both 90 degree, that means the left hand side has to be equal, right? So therefore, angle OPA has to be equal to angle XPB. Yeah. Now, if both the angles are equal, so this is only possible when X passes through the center. Yes, Martin? See, I am saying that this complete angle, right?
Is
And
it cannot
this,
be a perpendicular?
sorry.
Cannot be a perpendicular.
So, see, obviously, X is any imaginary point I have taken, right? Such that it is perpendicular on the tangent. I'm just saying X is any point. Actually, such point does not exist. I am just considering any point, imaginary point. I'm saying that it is perpendicular to the center. Now, if, sorry, tangent. Now, if it is perpendicular to the tangent, so this angle has to be 90 degree, right? And if I compare equation 1 and 2, so both the angles are coming out to be equal. Now, this is only possible. Now, this angle and this angle can only be possible when X actually passes through O, isn't it? I mean, X cannot lie anywhere else in the circle. It has to pass through the O. Then only this angle is equal. Is that clear?
Yeah, man.
Okay, so which is possible only if the line XP passes through O. Is this understood?
Yes, ma'am.
Yeah, so then only the angles, these two angles can be equal. So hence we can say perpendicular to tangent passes through the center. You can do one thing, Martin. Instead of this OP perpendicular to AB in proof, you can simply write this sentence that you have to prove that the perpendicular to tangent passes through the center. That you can write. Perpendicular to tangent